Okay, today we will see some introduction about the semiconductor physics. So I think you already studied the basic foundation in the electronic design devices and circuits, that is semiconductor. Semiconductor. What does semiconductor means? So the name itself suggests it is a conductor. Conductor means what? Through which the electrons will flow. So that is called conductor. Semiconductor means what? So it is also a conductor which will allow the electrons and which will stop the flow of electrons. In both the ways it can act. That means which allow the flow of electrons and oppose or stop the flow of electrons. So this is the very good property of semiconductor. Means if you want to make it as a conductor, you can make it, or if you wanted to make it as an insulator, you can also make it as a insulator. So that is why this semiconductor is very important material in the electronics devices. So what are the semiconductor materials? The semiconductor materials are silicon and germanium. So out of which we will use this silicon as a semiconductor material in the electronic devices making. Why? Because the silicon material is available in the nature very plenty. So from the sand we can extract the silicon material. So that's why which is very abundantly available in the nature. So that's why we are choosing the silicon material for the semiconductor. Okay. And we have different types of conductors, semiconductor materials. What are those? Those are N type material and P type material. So can you tell me anybody what is N type material, what is P type material? Anybody? Okay, very good. So how can we make it as a N type material and how can we make it as a P type material? By using doping. Very good. So I think you already know, but a little bit information I will give. So mainly we are using silicon as a semiconductor material. So for this, the outermost orbit, the valency electrons, four valency electrons are there. Four valency electrons. So if you take a semiconductor material, any material, suppose take this is a silicon material. This one is a silicon material. So if you wanted to convert this silicon material either into the N type material or into the P type material. So how can you make it? That is the question. The answer is simple. So by adding the impurities, So what are those impurities? Those impurities are boron and phosphorus. Boron and phosphorus. So if you the boron is having the outermost orbit is having a what are called I think uh, so okay, so if you add this boron atoms into the silicon material, then this silicon material will be converted as a p type material. Okay, if you add phosphorus atoms into the silicon material, then the silicon material will be converted as a n type material. That means when we say the silicon material is a n type material, so if you add phosphorus atoms into the silicon material, so the phosphorus atoms are having 5 valency electrons. So suppose say if you add one phosphorus atom here, then this one there are 5 valence electrons for the phosphorus atom. Then here another silicon atom is here, so this is also having 4 valence electrons, and here silicon is having 4 valence electron, and here another silicon atom will be bond with the neighbor electrons like this. I think you might studied in the intermediate physics, but just for recapitulation I am explaining. So like this, so they are fixed. So if they are joined, they are fixed. And as I told, the phosphorus atoms are having 5 valency electron. So one electron is free to move anywhere in the semiconductor material. So that's why if you add more number of phosphorus atoms into the silicon material, then the majority carriers will become electrons. Since the majority of in the material is electrons, then we can call it is a n type material, isn't it? Similarly, here another thing is what, if you add boron, then what happened, the boron is having only wait a minute, boron is having 3 valency electron. Okay, so 3 valency electron means I will draw. Is having 3 valency electrons only. So then what happened here? Here there is a absence of electron. So absence of electron is nothing but the hole. Okay, hole means what? Hole means what? It is a absence of electron. So since there is a absence of electron is there, then it is a hole. Then this electron will travel to this side, and then it is again travel to the another boron atom. Likewise, here the impurity atoms are boron, so that the number of majority carriers are hole. So earlier we are adding phosphorus atoms to the silicon material, so that the majority carriers are electrons. Why? Because there is a extra electron is there to travel along the semiconductor material, entire the semiconductor material. Similarly, if we add boron atoms, then the boron atom is having 3 valency electrons, 1 and 2 and 3. So these will be bonded with the nearest silicon atoms. So then there is no movement of electrons here, and but there is a absence of hole is there. Absence of electron is now become as a hole. So here the majority carriers will be the hole. So that's why if you add boron atom into the silicon material, then the majority carriers are holes. So if the semiconductor is having majority carriers of holes, then that material we will call it as P type material. Are you understand? So if you want, you can make it as a silicon material either into the P type or into the N type. So now let us see PN junction diode. PN junction diode. So if you add two materials P and N type material together, then it will forms a PN junction diode. So as I told already, P type material is having the majority of holes and N type material is having the majority of electrons. So you know something in the nature what happened, any material or anything will be travel from higher concentration higher concentration higher concentration to lower concentration. Is it not? Any material in the world, the nature will be travel from higher concentration to lower concentration, isn't it? Suppose if you take a water bottle full of water, then if you press the water bottle, then what happen? So the water will flow from higher pressure to lower pressure, so it will drop. Similarly, we already studied that P type material is having majority of holes. Majority of holes means what? Minority of electrons. Minority electrons and majority holes. So this side what happened for the N type material? Majority electrons and minority holes. Is it not? So as a tendency of this higher concentration to lower concentration and lower concentration to higher concentration, if you put the same material P type material and N type material, as a result what happen, some electrons, some holes will travel towards the N type inside and some electrons will travel towards the P type. So as a result, then what happen? There will be some stabilization. See, if both the side, suppose if you take a water tank level, suppose if you take like this, if you take two water tanks, and if in between if you connect one pipe, okay. So these are the two water tanks, and suppose there is a water here. Here also there is a water. Okay, if both the side the level is same, then is there any water flow? Is there any water flow? No. Suppose if you bend something, if you suppose if the level is different like this, if the level is different like this, one is upside, one is downside, then what happen? The water will flow from like this. Until when the water will flow? Until the level becomes same. Okay, whenever the level is same, then the water will not be flow from one side to other side. Similarly, see, the majority of holes will travel from this side to this side and electrons will travel from this side to this side. how much how much time it will flow until there is a equilibrium exists between the p side to n side. Whenever the equilibrium is there, then what happened, the movement of majority carriers traveling from one side to other side will be stopped. So that time, that is we call it as a, this we will call it as a depletion region. Depletion. So this thing will be happen by the nature. Okay. But suppose, for example, if you wanted to flow the electrons from this side to this side, then what we have to do? We have to apply some voltage between the n type p and n junction, that is forward bias junction. Okay. If you apply the voltage here, then what happen? So this is a positive side, this is a positive. Since it is a positive voltage, this will attract the electrons. By force, it will attract the electrons to travel through this wire. Like this, the electron flow will be happen. So in order to travel from electron from this side to this side, you must apply, you must break this depletion region. So that depletion region breaking voltage, we will call it as a threshold voltage. That is nothing but 0.7 volts. If we apply the voltage above the 0.7 voltage, then this electrons is eligible to break this depletion region and travel towards the attracting force, that is a positive force. So then the electron will travel from this side to this side, and there is a closed loop exists. Then the electrons will flow in the p-n junction diode like this. Okay. So why I'm saying this, you will get the in future. Just recapitulation. Is it clear? Right. Now afterwards, there is a see. Afterwards, there is another thing came onto the picture, that is called BJT. The another trend in the electronics, that is BJT. BJT means what? Bipolar junction transistor. So can anybody tell me why this transistor was introduced? Why this transistor was introduced? So do you know why this electronics came into the picture? Can anybody know the background of the electronics? Why the p-n junction diode is introduced? Why the BJT is introduced? Why they are manufactured? Can anybody know the history behind this? Anybody? Anyone? Okay. So the history why this is introduced, because in older days, whenever the electronics is not there, then they are designed computers actually. Computers. How they are designed computers? By using mechanical switches. By using mechanical switches. So which will occupies a very large area. It is a one apartment actually. It is one apartment area is a computer earlier. So afterwards, see what is a computer actually? It is nothing but zeros and ones, isn't it? Zero means off, one means on. So the on and off mechanism will be done by mechanical switches, by opening and by closing. Who is that? So by opening and closing, we will design a computers. So later on, it is very difficult to maintain this mechanical computer. So that's why they are thinking that somehow we have to implement the switches without the mechanical components. So then there is a device is developed, that is PN junction diode. See, this PN junction diode is mainly, you can use this as a mainly for on and off. How can you on this switch? By applying forward bias, is it not? How can you off this switch? By applying reverse bias. So same mechanical, so then after introducing, so previous this PN junction diode, there are vacuum tubes are available. Vacuum tubes. So after mechanical switch replacement is vacuum tubes, but the size of vacuum tubes are very huge. So then there is another revolution has came into electronics device, that is PN junction diode. So then the vacuum tubes are replaced by the PN junction diode by making on and off. Then after from the PN junction diode to, then it will be go into the BJT. Why this is introduced? Because see here in the PN junction diode there is a current is flowing. Some amount of current is flowing, but there is no control in this current. There is no parameter which will control the flow of electrons. That's why the BJT was introduced. So how the BJT is designed? So BJT is designed like this. There is a region. One region is emitter. Then another region is base. Then another region is collector. Okay. Another region is correct. So what is happen here? Emitter will emit the electrons, collector will collect the electrons, and base will control the flow of electrons. Okay, so that's why the BJT is introduced. Why? Because there is no control of current in the case of PN junction diode. That's why see another thing is introduced in the middle. Another thing is introduced in the middle, that is the base. So the base will control the flow of electrons. So that is the reason the BJT is came into the picture. So I don't want to explain the operation of this. I think you can understand. Next one is after BJT, there is another thing is introduced, that is MOSFET. So why they are going like this? The trend, why the trend is going like this? Why the people are going from PN junction to the BJT? Because there is no control. There is no control the flow of current. So that's why the people are moving towards the BJT. Then why the people are moving towards the MOSFET? Even the BJT is working very good. Then again why they are going to the MOSFET? What is the reason behind that? Because see the emitter will emit the electrons. Some current is coming, some amount of current is coming. So this entire current will not go directly into the current collector side. Why? Why this total amount of current is not going towards the collector side? What is the reason? Is it the emitter current is equal to the collector current in BJT? What happened? What is the equation for emitter current? Tell me. Where are you studying? That is the fraction. That is. See, emitter current is equal to the collector current plus the base current. So here the emitter current is not equal to the collector current. See, suppose you are giving some amount. Suppose 1000 rupees you are giving to one person. That is collector. So you are giving 1000 rupees, but the collector is not getting 1000 rupees, 900 rupees, and 100 rupees is going to the base. Is it good? Is it good or bad? Is it good or bad? So tell me. Hello? Are you listening? Yeah, tell me. Then why are you not giving answer? See, 100 rupees I am giving, but you are getting 900 rupees only. Is it good or bad? So it is a bad device. So how can we make it as a good? See, anyhow we should have the control. We should have the control over the current. And what you have to make? You have to ensure that this base current should not be go. Means if you give 100 rupees, and if you get also 100,000 rupees you are giving, and if you get the 1000 rupees, then it is good. And we have to minimize the flow of current into the base. So that is the reason the MOSFET was introduced. So in the MOSFET, what happened? The whatever the current is providing. So this is like this. MOSFET is looking like this. MOSFET. This is the MOSFET. So later we will explain in the clear operation and clear construction. But just to make the difference between BJT and MOSFET, I am just drawing this. So MOSFET is also same like a BJT. It is having the four terminals actually, but another terminal we will discuss later. So it is having source terminal, it is having drain terminal, and it is having gate terminal. Three terminal it is having. Another extra terminal it is having, that is called body. That is called body terminal. Okay. This is called P type substrate, and this is N plus region. This is N plus region. What is N plus? N plus means more number of electrons. There are material N type material. N type material means what? It is having the electrons, majority carriers. N plus type means what? It is having more number of electrons compared to the N type. Okay. So here source will emit the electrons and drain will collect the electrons, and gate will be used to control the flow of electrons between the source to drain. So the electrons will travel from source side to drain side. Okay. And here the gate will control the flow of electrons. But here in the MOSFET, the Ig current is equal to 0 almost. There is no current produced, or there is no current enter into the gate terminal, unlike the base terminal in the case of BJT. Are you getting the point? So whatever the electrons are coming from the source side, the entire electrons will go to the drain side only. There is no current flow into the gate terminal. Why the current is not going into the gate terminal? Because this is a gate terminal. This is a gate terminal, and in between gate to the this transistor there is another thing is there in between. Another material is there in between the gate to the substrate. That is what is this? What is this material? Tell me, anybody. This is oxide material. Oxide material. What is the property of the oxide material? It will act as a insulator. It will act as a insulator. Does insulator allow the electrons flow the electrons? No. So that is the reason the Ig current is approximately 0. So whatever the source electrons are there, the entire electrons will go towards the drain only. So that is the reason there is a revolution happen from BJT to the MOSFET. So here gate terminal is a metal. This is a metal. So metal, oxide, the p-type material is a semiconductor, isn't it? So p-type material is a semiconductor. That's why the name is given metal oxide semiconductor field effect transistor. So anyhow, before this there is a FET device, only FET device. So we did not discuss that, but anyhow, this is the main thing in the VLSI design. So afterwards, after invention of the MOSFET, it is leading. The VLSI design is leading by the MOSFET only. Understand? So then coming to the MOSFET, so now actual focus will be begins from now onwards. Coming to MOSFET, MOSFETs are broadly classified into two categories. Broadly classified into two categories. What are they? What are those? Enhancement MOSFET and depletion mode MOSFET. First one is what? Enhancement mode MOSFET and depletion mode MOSFET. Again, the enhancement mode MOSFET is classified into again two categories. One is N type, another is P type. P type enhancement MOSFET, MOSFET, and P type MOSFET. Similarly, in the depletion mode, again it is broadly classified into two categories: N type D MOSFET and P type D MOSFET. Okay. So we will discuss one N-type MOSFET and one depletion mode MOSFET. So that P-type will be just reverse of that. So nothing is there to explain more. So we can discuss N-type MOSFET and P-type MOSFET. N-type enhancement mode and N-type depletion mode. So in the next class we will discuss that. So but just the construction I will discuss today. So how the MOSFETs are looking like, I already explained. So any MOSFET will be designed on one material, on silicon material, that is called substrate. Substrate means what? On which you are going to design your transistor is called substrate. Okay. What type of substrates are having? Two types of substrate are available. One is P type substrate, another is N type substrate. But mostly available substrates are P type only. So that's why the substrate is P type substrate. But see, if you wanted to manufacture an N type MOSFET, then you required P type substrate. If you wanted to manufacture a P type MOSFET, then you require N type substrate. So suppose say this is a P type substrate, then you have to create the N plus source side and you have to create the N plus drain side. In future, we will see how this source and drain was introduced into the piece in the substrate. We will discuss in future classes. So then there is a insulator. Then another thing. Okay, this one. Then next, on top of this gate. So this is the gate, and there is a contact. Okay. So there is a contact. This is a gate, and this is source, and this is drain. So for simplicity, we will not use body terminal repeatedly. We remove the body terminal for operations and for some for the simplicity case only. So later on we will discuss what is the use of body terminal. So here we will call three terminal transistor, which are source, which is gate, and another is drain. So what is the operation here? Source will emit the electrons, collector will collect the electrons, and gate gate will control the electron, control the flow of. Who is that? I think people are not interested in listening to the classes. Okay, anyhow, make sure that your surroundings are clear. Okay, so this is a P-type substrate. Okay, so we will discuss the operation and comparisons between the MOSFET to BJT and comparisons between the enhancement mode and depletion mode. So actually this transistor is nothing but N-type enhancement mode MOSFET. So why it is called as a enhancement mode MOSFET? Why some devices called depletion mode transistor? What are the differences? That we will discuss in the next class. Okay. Any doubts in this class? If you have any doubts, you can ask me. Sai Leela? Anybody? Understand? All of you? Kinnara, Manasa, Did you understand? Pratyusha, Mahesh, 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 where are you? Mahesh, where are you? మరి సౌండ్స్ ఏంటివి వచ్చేది? కరెక్టే. అంటే నీది మైక్ ఆఫ్ చేయడం ఇంపార్టెంట్ కాదు బాబు. మీ సరౌండింగ్స్ మీరు క్లియర్‌గా ఉంచుకోండి మీరు. కొద్దిగా డిస్టర్బెన్స్ లేకుండా ఉంచుకోండి. ఎవరైనా గాని ఎవ్రీబడీ ఎన్ష్యూర్ దట్ యువర్ సరౌండింగ్స్ ఆర్ నాయిస్‌లెస్. ఓకే. So treat this class is also same like your classrooms. Okay, not this is not a time pass class. Okay, all of you maintain this virtual class also, real class. Don't make it noisy. Keep your environment clean, noiseless areas. You sit on in the noiseless areas. Okay. Okay. Anyhow.